15 pounds, or it'll tell us 13 pounds. So we will put 13 on our torque screwdriver and we'll tighten it because it has to be really, really tight so that there's no arcing inside of the breaker. Whenever we turn it on, there is going to be a little arcing because the contacts are opening and closing, but that's why the breakers are so thick, to contain that arcing that's inside. So as soon as I turn on my breaker, my power is going to go wherever I send it to, right? So I'm going to go ahead and run my wires, and then I'm going to go to another enclosure. I'm going to go into a box, and this box is going to protect the wires, right? Anything that I run here into this box, I'm going to make splices. What did we say splices were?
Wires together.
We're making a wire one again, right? So we have one wire coming in with power and we want to send it somewhere else. We can go ahead and connect them together and make them one again. So here with my wires, I go up and I might go to another box. For example, here, I might want to connect a light on this box. And in this box, I'm going to connect a switch. The S is the symbol for a switch in electrical diagrams. So wherever you see an S, that means that there's a switch. And then I might want also to connect a receptacle. This is the symbol for a receptacle in an electrical diagram. And then I might want to connect to another 3 receptacles, here and here, here and here. So from this box, I'm going to jump into this box, and from this box, I'm going to jump into this box. And here, I might want to connect to another switch. And here, I might want to connect another light. So I create the path for electricity, and inside of these boxes, all of my wires are going to be protected. And my splices are going to be protected with wire nuts. So what do we need here? We need enclosures. The enclosures are going to be equal to my electrical boxes, right? This is an electrical box, this is an electrical box, this is an electrical box. This is a round one, but it's an electrical box. Just that the round ones are usually used for lights. And the square ones are usually used for single devices. I might have enclosures that are for 2 devices. So I might have a 2 gang box, right? That one will actually contain 2 devices. For example, I want to put 2 switches. I would put it on a 2 gang box. Maybe I want to have 3 devices. I'm going to have a 3 gang box. In this box, I'm going to connect a switch, and a receptacle. How many of you guys have seen switches and receptacles side by side in the kitchen?
Yep.
All the time, right?
All the time.
So we have to have the right box for the right amount of devices. If I have 2 devices, I would use a 2 gang box. If I have 1 device, I would use a single gang box. And then 4 devices, 4 gang, 5 devices, 5 gang, 6 devices, 6 gang. And now they make boxes so that you can just connect them together. You can create as many gangs as you want to, because there's a lot of electrical circuits and you can make them however you want them. Yes?
In a 3 gang box, can it also be 3 switches?
It could be 3 switches, it could be 3 receptacles. It could be you're gonna see the different configurations that we're gonna be working on. So yeah, any device could go inside of that box. It could be 3 switches. Okay, so with our wires, we're creating a path for electricity. In this circuit, I have this switch turning on this light, and I have this switch turning on this light, and these receptacles are just there so that I can plug in my phone, my vacuum cleaner, my Xbox, PS3, whatever you guys have, your TV, whatever, your boom box. Those are general use receptacles. They're gonna have constant power all the time. Those switches right there are gonna have the power in the boxes, and they're only gonna allow power to go up to the light whenever you flip that switch, right? The lights are not gonna have power. If I were to send the power up to the lights, then as soon as I turn on my breaker, for example, this is a 20 amp. I have a lot of loads, right? I have 1, 2, and 3 receptacles. So I'm not gonna go ahead and put a 15, I'm gonna put a 20 amp circuit there. So I have, I go ahead and I flip this, I turn this on. If I send the power directly to the lights are gonna turn on, and the switches are gonna be useless. So I need to know how to connect in this box, how to connect in this box, in this box, in this box, and in this box, so that my systems will work properly. And this is what we call it wire diagrams, being able to understand what we can do with all of our wires. Inside of my Romex, either if it's 14.2 or 14.3, the green, the white, the red, and the black, what do they have underneath the insulation?
Copper wires?
Copper, right? All of them are potential, right? They all have a potential to carry current because copper is a good conductor of electricity, right? But depending on how I connect them together, that's going to be if my system is it's gonna tell me if my system is gonna work, or if it's not gonna work, or if I'm gonna have a short circuit. In a circuit, for example here, in between my hot, which is the black wire, and in between the neutral, there always should be a resistor. If these are all lights, one of the wires is going to be black and the other one is going to be white. There cannot be, the white and the black cannot be connected together because then I'm going to have a short circuit. Bless you. So just to make a difference between one and the other, this one should be my white wire, and this one should be my black one. If at any point of the circuit I connect them together, as soon as I turn on that breaker, it's gonna trip. I'm gonna have a short circuit because I always should have a resistor in between my wires, okay? So depending on how I wire them here, when I turn on the switch, I might have a short circuit, or my light will turn on. Or my light might not turn on because I didn't even bring power to the switch, right? So you need to understand how your circuits work, how the wiring system works, how to connect them properly, how to splice them, how to connect them to the screws to be able to create a circuit, a simple circuit, right? Okay, so does anybody have any questions so far? You stretching again?
So the circuit breaker cuts off current to the switch.
It'll cut off current to the whole circuit.
Right, okay, but a switch does not necessarily shut off the current up to the luminaire.
It will turn off if it's before the luminaire, it'll turn off the power on the luminaire.
So the conductor from the circuit breaker to the switch, if you shut off the power and you cut the cord, cut the wires, you're not gonna get shocked. Because the electricity.
On the breaker?
The cable that's connected to the switch.
If you turn off the switch here?
If you turn off the circuit breaker,
Well, this is the circuit breaker.
Right, so you
So
shut
if
that
I
off.
turn off the circuit breaker, I don't have power anywhere.
Right, okay, right. So you can cut the cable connecting to the switch. Literally cut it.
Uh-huh.
Okay, right, so you're not gonna get shocked in that instance, right? But if you didn't shut off the circuit breaker, you still got current flowing to the switch, right? And then you got cables running from the switch up to the luminaire. So, but if you were to cut those cables, even though the lights are off, you could still run the risk of shock.
Yeah. Funny story. When I barely started in this field, I would always go with my dad and help him out, supposedly, right? He says that I would fall asleep. I think that that's a fallacy. I don't think that I fell asleep while we were working. But he told me go ahead and cut off the pigtail from the microwave. You guys know which one it is? The extension cord, right? That's connected to the microwave. He told me don't throw it away. We can use it for something else, right? So I went ahead and I pulled out the microwave and I cut it, and then boom! Big explosion in my tool. Well, it was insulated, so nothing happened to me. And then right after the boom, he's like, "You should have disconnected it before you cut off the." I was like, "Okay, sorry about that." So in what you're telling me there, if you don't have the breaker off and you just cut the wire, automatically when you cut that wire, you're gonna have a short circuit. Because at the point that you're cutting the wires, you're connecting all of them together. That's what happened to me. But if you have the switch on the off position, you don't have power anymore here, in theory, if nothing else is passing through this box. Because some people might pass another circuit there from the attic, and they're just using it to splice a wire. So you think you don't have power here, but you might still have power here. So the best way to be safe is to first turn off the breaker, then take your multimeter, check for power here, and if you're gonna put your hands here, check for power there as well. Doesn't matter if you turned it off here. What if somebody sent another circuit and you don't know about it, right? So safety, safety, safety. You turn off your breaker first, then you go ahead and you start cutting wires if you need to cut them. But you never start cutting wires without making sure that there's no power in the box. Because I know it was my dad's fault, because he should have told me turn off the breaker first, or turn off the power first. It's never going to be my fault, right?
If you were not told.
No. As electricians, we have to think about it, right? So I was younger, I was barely getting into the field, and my dad told me, "Don't cut the extension cord," and I did. My pliers, they had a big hole in them because I created a short circuit with those two wires. And that could happen when you guys are stripping the insulation off of the wires and you leave some copper exposed. Eventually that copper is going to seep into the other insulation. It's going to burn it out, and you're going to have a short circuit in the walls.
And can that cause a fire
Oh yeah.
when you do
I'm thankful that it didn't cause an explosion on them, because I had pliers that were rated, right? So every time that we use our tools, we use the right tools. If I would have had uninsulated pliers, I would have gotten electrocuted right there, and that was it. But we were using the right tools, so that's why nothing happened to me. But that's how you have to be focused on what you're doing as an electrician, because a mistake like that can happen to anybody, right? Something like that, electricity is dangerous. It's not something that you have to be afraid of, because 99% of the time our circuits are off, right?
Yeah.
Before you start cutting, gotta test, make sure that even if you turned off the power, what happens in newer homes is that you turn off the panel, the solar panels come in. You turn off the panel, the generator turns on, right? So there's not only one power source, there's two or three. So, oh yeah, I turned off the main breaker. There's still power. Oh, I forgot the solar panels. So you can't just put your hands inside of the panels. You have to think before you start doing your work. All right, guys? I've given you guys so much information this week. We're going to go over it again and again and again, okay? So I hope you guys have a great weekend. And if you have any questions, I'm going to be here. You can come up to me and ask me questions if you need anything. But if not, the class is dismissed. Have a great week.
Thank you. Thank you so much for everything.